All right, all yours.
Okay, so the whole house inspection has so many components to it. And there's components that happen before you even arrive at the house. So there's what we call the pre-arrival tasks. There's the occupant interview, which partially can happen when you're actually having that initial contact over the phone or whatever that initial contact is, and then the additional occupant interview when you're at the house, and there's the site inspection and all the various things that we need to look at. So I'm going to go through these through the presentation. This is the basic process of what home performance is, a home performance contracting company. So there are third-party energy auditors, which is actually what I am. And then there's the bigger picture model of what a home performance contracting company would be doing. And that truly is really where the home energy audit is best suited, is for the contracting company that is taking on the home performance model. So I really thought when I started back in 2008 doing home energy audits that I should be out of business within a few years, because there should be all these home performance contractors out there who are able to do their own audits to bring themselves the information they needed to give all that value to their customers. And then when I started actually training people in how to do audits, when we had the home upgrade program throughout California, I thought for sure that I was training myself out of part of what I do, those home energy audits. Unfortunately, we haven't had the uptake in the home performance model that we had all hoped. So I still sometimes go out and do those home energy audits, but really it's part of a much bigger picture. And this is what that is. It's doing that test in, which is the home energy audit. It's creating that report from the findings. It's making the plan with the homeowners. It's executing the work itself. And then it's doing a full test out. For this presentation, the home energy audit process, we're going to talk about the first two, the test in and the report. Testing is one of the ways that distinguishes a home energy auditor from a contractor just going out to a home, meeting the homeowners, taking a quick look and giving their opinion. Testing provides quantitative, accurate information as to how various components of the house are functioning, which then informs us as to how the house as a whole is dysfunctional. These are the tasks that you're going to want to do in advance of actually going out to the home. And so part of this is also qualifying the client on both ends, whether it makes sense for you to sell them a home energy audit, and whether it makes sense to them that what you're offering is what they're actually looking for. So it typically starts out with a phone interview. And in that phone interview, we're looking to find out the client's basic motivations, what their wants and needs are, their level of understanding of home performance, and what they would be getting into in getting a home energy audit. We're going to start gathering and assessing the essential data that we will need to present them with our findings and recommendations. And so if we can get 12 months of utility bills before we ever go out to the house, that's ideal. Doesn't have to happen that way, but it is ideal. It gives a baseline before we ever walk into a general understanding of whether they're using more heating and cooling in terms of their energy dollars, or whether their base load, which is all the other appliances and electrical and gas uses they have in the home, which one of those is where they're spending kind of the most money, and it helps us direct some of our audit inspections. So then there's also taking a look at Zillow to get a look at the house to see what at least the county assessor thinks the square footage of the house is, and that's often a different number than the homeowner thinks, and that's often a different number than what we find when we actually go out and measure the house. Figuring out what the age of the house is, and then also you should just know your area and already kind of know some local environmental information about your area, but also you can take a look around to see, are there any particular industries or anything around that house that will also help guide you in your audit process. So the utility bills are very useful. They provide quite a bit of information as well as feedback from the work that we do. So we do want to gather those utility bills and do something called a utility bill disaggregation. And basically what that is doing is it's allowing us to separate out the seasonal heating and cooling loads, so the heating and cooling, and the base load. The seasonal heating and cooling loads can often comprise 40 to 50% of a home's energy consumption. In this example on this page, this is a home that has separate gas and electric bills. And so both need to be looked at. And basically what we are looking at overall is kind of the trend. And we're looking to see what the base load is that's used every month versus when they turn on their heating and cooling system. So electricity is typically the cooling system in a gas electric house. And we can see and calculate about what that cooling load is. And then on the heating side, we're looking to see what the base load is again, and then we can separate out the heating load on a gas and electric house. So I'm going to go through a quick utility bill disaggregation. This is something that actually homeowners could do for themselves, as well as being a very valuable tool for the auditor. This is an all electric house. And there's a few different ways to go about doing a utility bill disaggregation. This is absolutely not an exact science. It just gives us an idea, a pretty good idea. And so in this example, what was done was that the lowest dollar amount spent over the year is what was chosen as base load. So the first thing we need to do is get 12 consecutive months of utility bills. So if it's gas, if they have a gas and electric house, you need both. If it's just an electric house, you need 12 months of consecutive bills. You can choose that lowest dollar amount. I like to look at the actual energy usage. So while I do graph dollar amounts, I look more closely at the kilowatt hours used for electric and the therms used for gas. And that's how I choose, because I know that in my building stock and in my area where I work, the prices for my utilities go up and down. And so looking at the dollar amount is not necessarily the month that had the lowest energy usage. So that's something to take a look at and get familiar with. Another way of doing a utility bill disaggregation to start with is to actually grab the 3 lowest months. So in this case, it would be September, May, and April. Add the 3 up to the totals up, divide by 3 to get your average, and then choose that as your base load, is the average of those 3 lowest months, because base load does change month to month, day to day. And so that, that's another way that people will do a utility bill disaggregation, is choosing the average of the 3 lowest months. So we have in this house base load usage of about $404 per month, and then separating out the heating months, we've got about $1,900 for heating and about just under $600 for cooling. So then what do we do with that information? We just start kind of looking at it overall. So we extrapolate out over 12 months, the base load comes out to almost $5,000. The cooling load, like we said, is about $600, and the heating load is about $1,900. They're spending over $7,000 a year for their utilities, right? So right off the bat, we know that that's a high number once you kind of know your area and your stock and your utility rates, and you're thinking, well, this is probably, hopefully, a big house, and it is. We got the square footage, and it's 6,000, so it's a large house. They are definitely using quite a bit on base load, and they're using overall $2,500 for their seasonal heating and cooling load, which comes out to 42 cents per square foot. Where does that put you? Well, once again, there's something that you have to, when doing these utility bill aggregations for a number of houses, you start to get a sense of where houses fall and how much room you have to potentially make that home bigger by what in your area constitutes a good square footage amount per month. And that's something that as utility bills change, you have to keep track of and get a sense of. So often on retrofitted houses will typically range from about 25 cents to $2.50 per square foot for heating and cooling. And so that's the unretrofitted existing homes. This example of the 6,000 square foot house is actually from a bill disaggregation from a case study that was done on a number of homes. It was a few homes in Reading. And so there's these two homes that were right next door to each other in this case study. The 6,000 square foot home was actually with two geothermal heat pumps, two 5-ton geothermal heat pumps, and they were installed for a cost of $100,000. And we looked at what their metrics were. The house right next door was only 3,500 square feet, so a smaller house. It had a 2-ton system put in at a cost of $15,000. This was done by a home performance contractor. This house was not. The total heating and cooling costs for the second house came out to $317 for the entire year. And so these were brand new homes being built, and the home performance contractor got to take care of the energy features. They did the air sealing, they did the insulation, they did the heating and cooling systems. So their price per square foot came out to a nice 9 cents per square foot. So just seeing the difference and seeing the amount of potential improvement off of a home with something like 42 cents per square foot cost is the types of things that we can figure out during a home energy audit and then give as our goals to a homeowner. Another thing that the home energy auditor needs to be aware of is environmental and regional considerations. So what types of soils there are in your area, any soil gases that might be present in your area, if there's industrial pollution. We just need to be experts in the region that we work in, and we have to know the building science. As soon as we start driving up to a house, we need to start looking for clues about the house, which also include, what's going on with the neighborhood, what kind of, what's the building stock, what's the foliage like, what's the wind flows. There's all kinds of clues that we can be getting as we're driving up, as well as getting an initial look at the house. So right off the bat at this house, I can see that there's solar panels. So this homeowner already went to the solar solution and now needed to call me in because there were still issues going on with their home that were giving them higher energy bills than they expected, as well as problems such as condensation in between their double pane windows and some other issues. So people call you in for all different kind of reasons, and even after they've done something like putting solar on their homes, they find that their homes are not comfortable or still not working well. Once we get to the home, we need to do a thorough occupant interview. There's so many things that the occupants know about their homes that we can never find out in the day that we're going to be spending at their home. So asking them lots of questions about what's going on in their homes, if there's ever been any flooding, what the wind patterns are, finding out if the home is often unoccupied, how many occupants are in the home. And so it's just a full interview to find out what they know about the home that that it will help you in your audit. It's important for us to explain what we're doing. So explaining the tests that we'll be performing, explaining the time required for testing, which will come as a surprise to a lot of people, but as a single individual going in to do an audit in somebody's home, it's going to take a minimum of 6 hours, and that's typically only if there's just a furnace and one water heater and no air conditioning. Otherwise, it's definitely going to take a full 8 hours for one person to do all the inspections and testing that needs to be done. If 2 people are going in to look at the home, that shortens the time to maybe 5 or 6 hours to get all the data collected and all the information. So it's a full day commitment just to do the inspection of the home. And then, we encourage occupant participation for them to see, what exactly it is, we're looking at, seeing what the tests are. And some people are very interested and some people aren't. And, just letting them know that they are welcome to participate. So after the occupant interview and getting kind of a quick tour of the house from the occupant, both inside and outside, then you're really getting started. And these are, the way I'm presenting this is not necessarily, it's definitely not the order that it has to be done in. It just kind of helped me to attempt to make some flow out of what an energy audit is, because so much of what is going on in an energy audit is that, as I said, houses are systems, and so things interrelate so much. And so something you see on the outside makes you know that I need to check that on the inside, in that, that opposite wall on the inside, or that ceiling, or the attic, or the crawl space. So it's all very interrelated, and we're looking at very much the same things. It's heat flow, airflow, and moisture flow through the building. And so the exterior inspection is complete, looking at moisture, landscaping, the solar orientation, the roofing, the flashing, the windows, the doors, anything that's unusual. Right off the bat in this picture, we have to wonder, what is all this staining that is going on underneath these 2 recessed lights below this flat roof deck, right? So there are some things that during an audit, you're not going to be able to actually figure out during the audit, but they are flags. Some are redder than other flags, as to things that you need to bring to the homeowner's attention and potentially put in your work scope to say, this is something that we really need to figure out before we potentially do other things. So we're collecting that information and data. And one of the best ways to do that is taking lots and lots of pictures. Important to take lots of pictures so that you can remember the details of what you've discovered in the house, to include them in your report to homeowners. Homeowners typically are not going to follow you into the attic or crawl space, although I have had a few that have done that with me. So you can show them the pictures of what you found in those places rather than making them crawl up there with you. So taking a look at these 2 pictures, anybody out there want to tell me what they notice about either one of these 2 pictures? I'll give you a second to start to type in quickly what discoveries were made from these 2 pictures. I'll take a sip of water while everybody's doing that. Okay, so I have a no idea on the left, rat droppings on the right. Okay, thank you, Erica. So people keep typing. I'll move on because there is a lot of information, but On the left, this is a sealed combustion furnace, and the combustion vent is not actually connected to the combustion outlet of the furnace. So all of the combustion gases, meaning things like carbon monoxide, nitrous oxides, are spilling into, was an attic system over a hallway right by the attic access hatch. All of that is spilling into the attic right by this attic access hatch. So really important safety find that needs to be red flagged and told to the homeowners ASAP. On the other side, I see that somebody wrote in that the water heater is not properly vented. Yeah, so this is supposed to be an atmospherically vented water heater. It's a natural gas water heater. It's supposed to be atmospherically vented, which means there should be a draft diverter here. There should be a space here that where there's actually air coming through. And what happens when we don't put a draft diverter in a naturally drafted atmospheric water heater is that the combustion, any wind or anything that's coming by can actually come down the vent, and it can blow out, whether it's the pilot light or whether it's the burners themselves, it can blow that out. And now we've just basically got a great big gas leak going on because we've got this water heater that is firing with no fire. So there's just gas. And it's never going to satisfy because it's never going to heat up to the point at which the thermocouple says, oh, we're hot enough, we're satisfied. So that gas is just going to continue to leak, which is, so, it'll deprive people of oxygen if, say, it's in a garage, or if, say, it's in a kitchen or a hallway, or it can explode. So kind of a big deal. Wind is one of the driving forces. And so because of the pressures created by wind loading is the largest driving force of air infiltration into a home. So it's something that we need to be thinking about and finding out about when we're looking at homes and how well they're air sealed or not. And so the wind also therefore causes changes within the internal building pressure. And this can be lessened by things like windbreaks, such as upstream trees. Conifer type trees can be considered on the north and west as windbreaks, while deciduous trees should be considered for the east and south sides because they lose their leaves in the winter. So it allows some solar heating in the winter, and it provides shade and a windbreak in the summer. And this slide gives you information about the fact that 2 times the height of a tree provides a wind break of up to 10 to 15 times the height of those trees. Foliage in general needs to be carefully considered. It can provide shade, it certainly can be aesthetic, but we need to consider the negative effects as well, such as how will the roots affect the foundation? If vegetation is too close to a building, will moisture be held up against the structure? Most of the claddings in our homes are what are called reservoir claddings. They absorb moisture into them, and we need them to be able to dry at least in one direction. And so if the plants are there and holding moisture against them, then they're going to want to dry to the inside. Which isn't our best choice. We really would prefer that they absorb that moisture and then dry it back to the outside as well. So it's important to have a capillary break, a break between vegetation and the siding of our homes. Plants also invite insects, ants, termites, and so we need to provide space between the plants and the house to avoid any negative impacts, while still allowing us to take advantage of their beauty, their shade, their buffering abilities from the sun and the wind. So as this home energy auditor, we're looking at this whole broader range of things that people almost think are none of our business, And so that's something that we need to gauge with the homeowners, but let them know that these things are important in the bigger picture of their home and their home's durability, which is part of what we're doing with the home energy audit. So how does water enter our buildings? Well, through leaks, surface water, flooding, groundwater coming up, vapor from just the soil itself. And then of course the interior things like taking a shower, just breathing, bathing, cooking, all of those things. Moisture in and around our homes is the leading cause of structural damage. So it is a big deal, and we absolutely have to figure out what's going on with water in and around the house itself. So just a few little factoids. A 5-minute shower releases just over a half of a pint of water into the home, whereas ground moisture, so from that crawl space underneath the home or the ground underneath a slab, that moisture, which is highly variable, can be like as much as 105 pints in a single day. So if we find moist soil around the home touching the structure or in the crawl space, that is tremendously significant, because even what looks like dry soil is contributing, up to 105 pints in a day. So we need to be looking for clues, and basically it's the source, the pathway, and how exactly is it being transported. This was one house where it was all pretty obvious. So at the audit itself, I could, figure out what's going on here. The rain gutter is sloped incorrectly. It's also got some debris in it, so that's not helping. And it's moving down the wall. And from seeing this from the outside, I knew that I should check the wall on the inside and see if I could see if there was anything that was actually coming through, if there was any problems on the inside that were noticeable. And unfortunately, there were. The paint was peeling and bubbling on the other side. This house is an older house and the walls were uninsulated, which on the one hand gives the home drying potential, but so much water would come down from this wall that that cavity was having problems. And if that cavity had been filled with insulation, there is absolutely no doubt that that insulation would have been holding the water in there, and there would be mold and rot inside that wall. So here's just, just other things that in terms of moisture that, you see. And so the thing is, you're just using all your observational skills to figure out that heat flow, that airflow, that moisture flow through our buildings. We've got a downspout that would be dumping water just directly against the house itself, not what we want to have happen. Problems with the drainage from the roof up above dropping onto this little parapet roof here that isn't sloped properly, that the water is ending up going against the side, and there's biological growth happening. This is what I find to be the largest problem with water and our homes here I'm in the Southern California area, is that our homes tend to get watered almost more than the plants around the house get watered, that the sprinklers and irrigation systems are watering our homes. And our homes aren't going to grow that way. They're going to grow things like biological growth. They're going to cause moisture issues within the walls, and some of that moisture is also, it's going to go into the foundation, through the foundation, into the crawl space, and then up into the home, causing issues inside the home itself. So all things that we need to be considering making our recommendations to homeowners about how to direct water away from and out of our houses. So foundation drain tiles that carry water away from buildings to daylight. If the site does not allow the drain to go to daylight, then special care taken to make sure that the moisture stays away from the foundation. Gutter systems, just taking control of moisture as part of our efficiency upgrades is really an essential first step towards a successful project. And in many instances, it needs to be what we call non-negotiable. So there are instances where things are going on where we can't do other things because they would just make the problem worse. So that home where the water from the rain gutter was not draining properly and was draining down the side of that home, I would never, ever allow them to put, well, so allowed, in terms of my recommendations to them, I would not recommend that they put insulation in that wall if that rain gutter situation does not get fixed, because I would just be setting their walls up to rot by putting insulation in them. So that would be a non-negotiable in terms of wall insulation, on that wall. So there are these things that understanding the flow and the drying potentials of moisture and what we do to make homes more efficient, such as putting insulation and uninsulated walls, are at odds with each other and become non-negotiable if we don't deal with the entire house as a system. Then there's, of course, just looking, for deferred maintenance issues, which once again seem to a lot of homeowners like that would be out of the realm of what a home energy auditor would do. But once again, they can be these non-negotiables, and the durability of the building is so important to what we do. So helping a homeowner understand the broader picture of what a home energy auditor does is important so that you can bring these things to their attention. So we've got a column that's been desiccated by termites, and then we've got all kinds of debris in a rain gutter, so telling a homeowner, hey, we need to get the rain gutters cleaned is nice and easy. As a home performance contractor, it also would not be a big deal to have in the work scope that you could replace that post before it just completely decides to stop standing up out of habit, which is basically at this point what it's doing, is just there because that's its habit. And then on the outside of the house, we want to begin to sketch and draw the house. Drawing the house helps in a lot of ways, helps you just remember kind of the layout of the house, gives you an accurate square footage, because often the county assessor is wrong, and often the home building inspector didn't measure accurately, and the homeowners have typically not actually measured the homes themselves. So getting your own measurements gives you that accurate square footage and volume, which you need for a load calculation, to mark architectural features, just to figure out how many bags of insulation might be needed for the home. It's very helpful and good practice to do a sketch of the home. So then there's the interior inspections, and they're not a whole lot different than what we're looking for with the exterior inspections. Quickly about this picture, it's not about this cute little toy horse. It's about what's hidden behind the toy horse and the cabinet that's in front of it. Noticing that the supply and returns grills of a forced air system are blocked is an important discovery in terms of people who are saying that they have comfort issues, right? If they're blocking the way that the conditioned air is coming into the home, that is part of the problem of why their home is thermally uncomfortable. And so is it just a bad place for the supplier return to be? Is it just them not understanding that this is how the air comes into the home and is moved through the home? So those are some of the things that we need to notice as we're going through the home, to have those discussions with the homeowner. Moisture, once again, just noticing. And something like this is one of those things that you typically can't figure out during the audit itself. Now, this was, I think, after a rainy day. So seeing just how wet this is with a moisture meter and just in touching it with your hands can give you a sense of just how current these stains are. If it wasn't just after a rainy day, there's no way to really know. And this is one of those things you would ask a homeowner is, when did these stains happen? And is there condensation problems or water leakage problems that you've noticed through these windows? Indoor air quality in our homes, just that there was mold growing, back here. When you see these signs of just what a lot of homeowners feel are dirt and don't understand why they can't clean it, this is signs of air leakage through the air distribution system. So it's a clear sign that there's air leakage. This the boot that's behind this grill is not sealed to the interior wall finish, and because of pressure differences, the dirty air is coming out and some of that dirt is impinging upon the wall itself. This is one of those things that goes all the way from the attic into the house. It's clues, right? So I saw the back of a couch and I saw that there was this outline of the switch plate on the back of the couch. So it tells me that there's definitely air leakage going through that switch plate. So with the blower door on, I used some smoke to see that, yep, air definitely is going up into this wall system through this switch plate. And then going up into the attic, what do I find is unsealed top plates. And on top of that, I find that there is a termite insecticide that is sprinkled throughout the attic and definitely over and around these unsealed top plates. Then there's more indoor air quality issues. There's a lot of those that you find and see that you can relate to air sealing, as well as the various combustion appliances and cooking that goes on within the home. These are dryer vents, and there's very specific code rules about dryer vents. And so this definitely violates all of those code rules about dryer vents. This is the crawl space is right on the other side. So this is a great big air leakage path between the house and the crawl space. Lint could absolutely get trapped in a turn like this and a turn like this. In a dryer vent, which is a fire hazard. There's so many dryer fires every year, and it's things like this that cause those. This is how it snakes then through the crawl space itself with these great big P traps in it, and it's much too long of a run without a booster fan. So you just, you follow the clues all the way along so that you can figure out what your recommendations are. You need to figure out whether you can shorten, first of all, straighten this out, shorten it up to the proper code lengths, plumb this properly so that it doesn't have these large bends and is actually meeting our code rules. Can we find a different place to get the drier combustion gases out of the house? Just all the discoveries that we need to be making. Here's some clues to pressure imbalances within a house. Walking into a house and seeing a fireplace that has, once again, the soot staining the mantle. That tells me that all of the smoke is not going up the chimney. That smoke is being drawn into the house. And the only way that that can happen is if there was enough negative pressure within the house so that the combustion from the fire is not all going up the chimney. So that's telling me that pressure imbalances happen. So then I can start asking other questions. Do you notice when the smoke comes out? Does it happen? Do you happen to be using your furnace at the same time that you're using the fireplace? Do you use the fireplace and not open any of the windows in your home? So there's a back and forth between what the homeowners might know is going on in their homes without actually knowing the why, and you knowing what clues are telling you about, say the pressures in the house, and trying to suss out what's going on and how you can fix these things. And then this was a flame rollout from a furnace. And once again, the only reason that's going to happen is if there's a pressure imbalance in the area of the furnace itself. More pressure imbalances, it happens with water heaters, and this is a floor furnace on the left where you can see signs of the heat and combustion gases coming out. Air leakage paths are huge. They are huge for keeping the kitchen conditioning in our homes. They are huge for indoor air quality issues. They can be as small as this hole for the speaker system into the attic, and easily sealed if somebody realized that it's an air leakage pathway and that it matters. Or they can be as large as seeing a ceiling that is a tongue and groove ceiling like this, which is pretty much just a complete air leakage pathway unless somebody paid attention to the proper details when it was first installed. And you can tell from the blower door will help you show whether that's the case, whether it's a great big leakage pathway or whether somebody actually paid attention to the right details and made sure it was air sealed. Other air leakage pathways, the interior stairs. So the carpeting happened to be taken off these stairs when I was at this house. And so I could see the air leakage pathways and that they're unsealed, particularly on exterior walls. There are problems behind baseboards. You can see that these are just pathways up into the wall system, which takes us into the attic as well as into the crawl space if it's on a crawl space. Often if a house is carpeted, you will see dark impingement, dark stains at these seams. And we think as homeowners that I'm just not good at cleaning my house. But really, you can't. The dirt is actually impinged, and it's because of the pressure differences that are causing air leakage. And so that dirt is actually a clue to the fact that it's an air leakage pathway. And then there's ventilation that is so critical in our homes, and in most existing homes, ventilation has not been paid attention to in the way that we know it should be nowadays. There used to be a lot of passive ventilation in homes, and this was in a kitchen. And so often they have been blocked off and then not replaced with an actual kitchen exhaust hood, taking the combustion gases from our stovetops and ovens out of the house. And then in a lot of our older homes, there were just holes cut, particularly in closets, as passive ventilation for the closet. And those are just air leakage pathways, and knowing what's in attics, they're absolutely part of our indoor air quality issues going on in a home. We also need to be looking for, just any ventilation that is in the house. And then when we get to the diagnostic testing, we can test to see what the airflows are for those fans and report back whether they're moving the right amount of air. And then also looking at their ducting systems, whether those are going through attics or crawl spaces when we go to those inspections. The lighting in our houses, especially in our older homes, there's still a lot of icing that actually lighting that cannot have an insulation in contact. So IC in contact or airtight recessed light cans. And just looking at them, particularly from inside a home, we can't tell. We need to remove trim rings and look to see if there's the label. So looking for the model, which will hopefully, which will tell us whether it's IC. This orange label tells us it's ICAT, which is insulation contact airtight. And so we definitely need to find out, because we want insulation. Most of our attics, that's where the air barrier is at the ceiling level where those lights are put in, and we need to know whether insulation can be in contact with those lights or not. And of course, we're always looking for safety issues. On the left here, just to let you know, this is flex gas line going through the furnace assembly, and that's not legal, mostly for its seismic safety. In an earthquake in particular, this line can be very easily severed. So it needs to be hard pipe going through there. And this is very typical on older homes, is finding this. There's been combustion gases condensing outside of the burners in this furnace. And so there's something going on. There's some kind of negative pressures, problems going on with the furnace. So after you've done the full interior inspection and picked up whatever clues you can, now you also have a sense of where you should be looking in the attic and the crawl space, beyond just what you find there, of things that match up to what you saw in the house or potentially outside of the house. So like duct systems and vents, you should have noted kind of where those were. So you look to see, what's going on. Is that bathroom exhaust fan, is that actually vented? Is it vented to the outside? What is that duct run like? This is, through an unsealed top plate, all kinds of electrical going through and just completely unsealed. And throughout your inspections, and especially once you get into the attic and the crawl space, you're always looking for anything that tells you that it wouldn't be safe to do a blower door test at all in this home. Or maybe it tells you, I shouldn't depressurize this home with my blower door test, but at this point, from what I've seen, I can still pressurize the home with the blower door test. So as you're going through a home, you're going through all the tests that you have in your bag of tricks and thinking, all right, what are the best tests that are going to help me give the best information to myself and the homeowner, and what tests are safe to perform, and in what way are they safe to perform, or are they not safe to perform, and I'm going to have to forego that quantitative diagnostic information because they're just not safe to perform. So crawl spaces. When we're in the crawl space, we need to remember that it's not a dry space. This white stuff is called efflorescence, and it is minerals that are brought as water evaporates through substances, so not just concrete. They leave behind some minerals, and this is the telltale sign that water has been evaporating through. And so this makes me want to know what's going on with the foliage and the landscaping on the exterior of this crawl space. And so now I can think back to that exterior inspection, or when I crawl out of the crawl space, go take another look and see what's going on. Possibly their damp proofing wasn't done well. The soil may be up too high, whatever it is. We want to figure out why exactly is enough water coming through that we're getting this efflorescence. Also, this was a powder dry crawl space that I was crawling through, and yet there were plants growing in this crawl space. And this is actually the same crawl space. There was basically an entire tree that somebody had, cut off underneath there, and it still overall was doing well inside of this very, very dry crawl space. So it's just important to remember they are not dry spaces. And the main solution to that, I will convey with this little story. This was found in an attic. And so what is this telling me? Well, what's going on that this was moist and soft, where the roofing nails were coming through in the attic. And this picture doesn't show it so well, but where all of the roofing nails were coming through the attic, the tips were all also rusted. So this was actually a home performance contractor up in the Mount Shasta area. And this is what he discovered in the attic. And he had been called into this home because there had been tremendous moisture problems. This home was only 3 years old when he was called in. And from the moment it was built, there had been condensation on the dual glazed aluminum framed windows all winter long. And water was dripping from the windows. The sills were warped and stained. The homeowners were constantly putting towels on the sills to absorb the water. The drywall around the windows had black mold growing on them. And the contractor was taking a look around, was up in the attic, and found this clue. Brought him down into the crawl space. And overall, the crawl space appeared to be fairly dry. But what the contractor did, because of his understanding of building science and how air, heat, and moisture move, the house was on a raised foundation. So he did air sealing at the subfloor levels in the crawl space, that ceiling of the crawl space. He did an air sealing work scope to mitigate that connection between the crawl space and the house. And he laid what's called a ground source vapor barrier, which is basically plastic laid out over the soil of the crawl space. And the last thing that he did is, once we lay that ground source vapor barrier, we are allowed to reduce the amount of venting in a crawl space. So he reduced the venting of the crawl space as well. And all of this within a few days solved the moisture problems within the house. So this is just another picture of just efflorescence. Basically, it even happens on the soil itself. You'll see the efflorescence. You can see that the water is coming up and leaving these signs that it is coming up. And this is what a ground source vapor barrier may look like. So basically, it's just plastic encasing the soil of the crawl space. There's all kinds of air sealing opportunities in crawl spaces. Huge, because that's often so much of where the plumbing goes through. And so there's just all of these opportunities for air sealing in a crawl space. You'll see the undersides of bathtubs as huge, huge holes. The plumbers just cut these tremendous holes in the subfloor and don't think to seal them. There's all kinds of deferred maintenance that you'll find in crawl spaces as well. And indoor air quality issues, a disconnected vent. And so breathing that crawl space air kind of very directly, and any kind of pressure changes that happen that might make the house a negative pressure to the crawl space is going to draw a lot of air from the crawl space up into the home. And with stack effect, particularly in the winter, that's where the drive is. It's from low coming in and then the hotter, warmer air exiting out at top. So we get a lot of movement that way in the winter and so a hole like that is an important issue. This is, unfortunately, we find a lot of dead animals in crawl spaces. That was a poor little skunk. And then attics. Normally we find lots and lots of rodents and sometimes birds and other things up in attics, and we find the traces they leave of themselves. Insulation. We typically can only tell if there's insulation in the walls by asking a lot of questions, by probing the walls around switch plates and things like that, and with infrared. The infrared is difficult to use in Southern California because the temperatures are just so mild that it's hard for me, particularly during an audit, to get the temperature difference that I need to be able to get good infrared imaging. Because you do have to set the whole house up and make sure that it's either heated or cooled so that it's warmer or colder than outside so you can get that temperature difference. But the infrared camera can be helpful, and the blower door can assist with showing air leakage pathways using that infrared camera. This is a knee wall that either had completely missing insulation or really in all probability it was poorly installed insulation. And with knee walls, very often you can then go up and visually verify what you might have caught on the infrared camera. You might find things like the insulation just kind of falling away from that knee wall. And then just as an aside, what we see in this picture as well is a very poorly ducted ventilation fan. There, with a huge bend like that is going to be very restrictive to airflow. Then, of course, lack of insulation and things like interstitial cavities. So cavities within the home that you're not going to see inside the home, but you often see in the attic and crawl spaces that they go, and often they will go all the way from an attic to a crawl space. You'll be able to see the dirt of the crawl space through an interstitial cavity. And so these end up being tremendous chimneys of heat flow through the house, which makes conditioning the house very difficult. This was in a house, this is in an attic. The plumbing was run fairly high in the attic. And during the summer, the homeowners basically never got cold water. The water lines were getting so warmed by the attic air that they were never getting cold water, and they had a toddler, and often the water was pretty darn scalding. So they definitely wanted to know why it was they couldn't get cold water in the summer. And that was, pretty simple thing to figure out. Then, of course, you'll see if there's forced air system, you'll see the ducts. You'll be able to make an assessment of how those ducts are run, whether they're pulled up against, say, a roof deck, and there's going to be lots of conductive losses, whether they have bends in them that are going to be restrictive to airflow, getting the level of the insulation on those duct runs. Wind washing happens. So even when we've got insulation put into our attics, if the proper details are not paid attention to, that insulation can get blown away from areas of the house. We call that wind washing. And so definitely in vented bays, we would expect that to happen. And so what should be installed is a baffle, so that the air that comes in through that vent does what it's supposed to do, which is basically to go along that roof deck, pulling warm air out of the attic and then having a high vent somewhere up higher. But there's also a lot of unintentionally vented bays in that the fascia board hasn't actually been sealed. And we get wind washing all over the place through the attics through these completely unintentionally vented bays. These two pictures are of the same attic, And the question is, which of these can lights can be in contact with insulation and which should not be in contact with insulation? So if people want to quickly tell me right or left, the question is, which should not be in contact with ventilation, right or left? Okay, I'm getting some answers. Thank you for playing my game. So the left one is the one that should not be in contact with insulation. And some of the only ways to actually know for sure is that you can, every once in a while, there will be a label where you can see a model number, and then you might have to Google that model number to find out whether it can be in contact with insulation or not. This kind of thing gives you clues, but you really need to look up the model number. And the other way, of course, is to be in the house and pull that trim ring and make sure, because a model number should be inside the actual fixture itself, the luminaire, to find out whether it can be in contact. And that's the same with this one, is that you start to suspect that looking at this one, it is very typical, the look of an insulation contact, airtight can, but once again, you need to confirm that. And obviously these were in the same attic, and it was completely the opposite of what should be happening. We need to evaluate ventilation. The exhaust fans in this house, the bathroom exhaust fans, were ducted to dryer boxes. So this is absolutely not proper way to vent ventilation. It needs to go completely to the outside of the building and not have any pathway for that air to come back inside. This was a bathroom exhaust fan that wasn't even ducted, and the cover was not even taken off for it to be ducted. Junction boxes, they need to be covered, and we can't be blowing in insulation or putting insulation in attics that are going to cover junction boxes that do not have covers on themselves. Just looking for all kinds of safety issues, and a lot of them do end up being wiring issues. Low voltage wiring needs to be able to be moved up above insulation level. There shouldn't just be loose wires that are not in junction boxes. So finding those kind of things, and these once again are some of those non-negotiables, that you can't put insulation over those non-contact insulation contact rated recessed lights. You can't be blowing insulation over uncovered junction boxes, and all these things. Those are non-negotiables that need to get fixed before you then say go ahead and blow insulation into an attic. These are some fire hazards that you might find when there's not proper clearance between a chimney and wood. This bat, the paper facing actually has a warning on it that says this facing will burn, do not leave exposed, cover with approved building material in contact with facing. So basically this is upside down. So whenever you see paper facing upward in the attic or outward in the attic and a knee wall, it's upside down. And a lot of do-it-yourselfers think that it's there to keep the fiberglass fibers from scratching them up and being annoying when they're installing it, or from floating around in the air after it's installed, and that's not the case. It's a vapor barrier, and it needs to be facing the drywall. Some other health and safety hazards that are very typical to find are breaches in the garage firewall. asbestos that is friable. So knowing what materials probably contain asbestos, or when you see labels on them, knowing that they absolutely do contain asbestos, and then seeing any kind of breaks and tears in them means that those asbestos fibers can be getting airborne, and they need to be properly removed, remediated, sealed before work can be done. And once again, you don't want to bury things like this in insulation. So this is just some more pictures of asbestos containing materials, in particular the wrap on this air handler, and then just random pieces from poor remediation jobs are very typically found in attics. The mechanical systems and diagnostic testing. So most of the testing is done on the mechanical systems and on the enclosure itself. And there's visual inspections that also need to be done on these systems. Here's kind of a list of the most common performance testing that we do. Blower door testing, IR inspections with or without the blower door, the 3 kind of main duct leakage tests, measuring the system airflow for both the heating and cooling system and the ventilation that's in the house. So whether that's a balanced ventilation system or say bath fans. There's something called the heating stratification test, delivered capacity test, figuring out how much capacity of the heating and cooling system is actually being delivered into the home, static pressure on the heating and cooling system itself. There's other pressure testing. You can do zonal pressure testing across doors. Then there's the watt draw. How much literal energy usage is the HVAC system actually using versus what it could be using? And pool pumps. Pool pumps are a huge energy usage, particularly in our existing homes before the variable speed pool pumps were available. And then water heater, you can do various efficiency testing on water heaters to see how well they're functioning. So the blower door is one of our main tools that we use, and there should be hopefully in fourth quarter of upcoming webinar on blower door testing itself. So be looking out for that. But it quantifies the air leakage, helps us locate where those air leakage paths are, helps us in our air sealing efforts to know how well we're doing, and then of course quantifies that final result that of our air sealing efforts. And then if you're doing duct leakage to the outside, it's a necessary part of that test. The blower door is built by 2 main companies, RetroTech and Energy Conservatory. This is an Energy Conservatory blower door, and it's set up for a depressurization test in this home. The manometer is the main pressure testing piece of equipment. It's the ones that we typically use are dual channel differential pressure gauges, and both RetroTech and Energy Conservatory have a few that are out there. They're all very good and very accurate. And then there's the infrared inspections. And so infrared can also help us pick up moisture as well as air leaks, as well as how well or how poorly insulation is installed and thermal bridging issues. You do need to know and understand what's going on with your infrared. So there's trainings out there to learn about how to interpret what you're seeing from your infrared camera, because there are certain surfaces that can deceive you and basically kind of lie to you. So it's important to to do some training, and particularly if you're looking for moisture issues with an infrared camera, is understanding how to figure out what the infrared camera is telling you or not. Then there's the duct testing. And so our duct systems, once again, RetroTech and Energy Conservatory are the 2 companies that make duct testing equipment. Next month, there will be a webinar on duct testing. So you might want to take a look at that webinar. And the duct test is is more than just duct testing. It actually tests the whole entire distribution system, which is the air handler through the entire duct system out through the grills. It's any leakage throughout that whole entire system. The three basic tests are total duct leakage to the outside, and the half Nelson, and those will all be talked about in detail in the duct testing webinar next month. The duct testers from both companies are interesting because they're multifunctional. They can be used as powered flow hoods. They can be used in extremely tight houses as the blower door fan. So instead of the bigger fan for the blower door, you use the duct testing fans as for your blower door in tight houses, such as a passive house. And they can also be used to measure total system airflow. So not only the leakage of the whole system, but they can actually tell you what the total system airflow is when you set them up for that test. And here are some other airflow measuring devices. And these devices are great for our exhaust fans and our supply grills and registers to tell us how much, whether those exhaust fans are actually moving the amount of air that they should to exhaust pollutants, and whether the supply registers or grills are actually delivering the amount of air that they should, that the overall system should. The flow finder on the left is the most accurate device, and it's a powered flow hood. The Alnor low flow bolometer on the left has definite accuracy problems because it's not a powered flow hood. And so it's a good entry level piece of equipment so that at least you can measure airflows and be within the ballpark, but it's not particularly accurate, and it does cost probably, I want to say it was like $1,300 or $1,700. It's up there in price, but the flow finder is over $3,000. It's like $3,500 or $3,800. So, but they're so important as pieces of equipment that anybody who can make the investment should absolutely be aiming to get a flow finder. Heating stratification is one of the main tests that we can and should be doing on the heating system. It basically it's a scorecard for kind of three things about the heating system and the house. It tells us whether the heating system is providing thermal comfort in the house. It is able to kind of give us a score of unacceptable comfort level, good comfort level, excellent comfort level in terms of how the heat is actually mixing in the house. It tells us about the system sizing. It can tell us whether a system is undersized or oversized for the house. And it tells us about the heat loss across the ceiling of the house, which tells us about the temperature differences and how well the air barrier is, if the air barrier is supposed to be at the ceiling level or not. And so therefore how much the heating system might drive infiltration through the house in stack effect. And that test takes an hour in and of itself to perform. The duct test, it takes kind of a long time to set it up. And then the test itself is very quick, and the blower door doesn't take that long to set up, and the test is very, very quick to do. So delivered system capacity is a test that tells us out of the capacity of the system that you're testing. So if I have a 5-ton system on a house and I want to find out, is it delivering 5 tons of capacity to the house, this is the test that would be done. And that test means that I need to be able to measure all the airflows of the supplies in the house as well as the returns. And I need to get the temperature of air at each of the grills. And from that, there's a formula that's used to calculate out how much capacity is actually being delivered to the house. External static pressure is another great test to do to our heating cooling system. It's kind of like taking your own blood pressure. telling how well that system is operating against the components that are hooked up to the system itself. So the air handler that comes from the manufacturer is rated for a total external static pressure, and everything that is attached to that air handler, from the evaporator coil, a filter box, the whole duct system, the supply and return plenums, the grills, everything past that is adding resistance and pressure against that air handler. And we're measuring to see whether we have created a system that is too restrictive to really deliver the capacity and the airflow that will provide comfort in the home. So it's a pretty darn quick and easy test to do to find out whether we're within the specs of the manufacturer or not. Just for your information, that is a terrible reading. This system is incredibly restrictive and way over the total external static pressure of the manufacturer. The total system, for the total external static pressure for this system was 0.5, and the supply side of this pressure is over 0.5 in and of itself, and the return side of pressure on this system is almost 0.4, is almost the entirety. Then finding out how much energy are these pieces of equipment actually using. So typically we can use something like a kilowatt to find out how much energy, how many watts the air handler is using when it's turned on. And then we need a power quality gauge to actually measure at the condenser how much energy the condenser is using. Then there's pressures across doors. When we have the heating and cooling system on, we need to have air needs to be able to get back to the returns. And so we really want our systems to never cause more than 5 pascals of pressure difference if we have to close a door to a room. 3 to 5 is good. And so this is an easy test to do with the manometer, to go around to the various doors, close them, and see what the pressure is across the doors. And then measuring the pool pump watt draw. So, and not only measuring the pool pump watt draw, but with pool pumps, we can very easily figure out how long the pool pump is running by looking at the timer system and extrapolating from there how many hours it's running, how many watts it's using when it's running, and figure out just how much energy it's using. I'm doing good. So I wasn't sure with this abridged edition, just how quickly I was going to make it through this presentation. So combustion safety testing and the combustion appliances. Most homes out there, although there's this wonderful huge push now towards electrification, we still have an awful lot of homes out there that still have gas. And so we need to be able to test those combustion appliances to figure out how well they're functioning and what we need to do to keep them functioning safely if we're going to be doing upgrades to the home, and whether we absolutely have to make the recommendation that not only would we like to electrify, but really, if we want to meet your goals as you stated to us, these appliances need to become electric. So we need to do visual evaluations, and we get all kinds of visual clues from our combustion appliances. We can see that combustion gases are actually leaking out of this induced draft system. A lot of people are under the impression that induced draft vent systems don't leak. And this tells us that, to the contrary, they absolutely do. This is the combustion gases having condensed on the metal and dripped down. These are our basic combustion safety tests. There's the visual inspection on all of our combustion equipment. There's Testing for gas leaks is one of the roles of a home energy auditor, is going along all the gas lines, testing for gas leaks, setting the house up and the appliances up for what's called worst case depressurization, where we're creating kind of that worst case scenario for a combustion appliance. So not doing something that would not happen in a home, but creating actually a scenario that could potentially happen in a home, or that would affect a combustion appliance and make the area around that compliance depressurized, which will cause problems such as pulling the combustion gases back into the house rather than allowing them to exit out a vent system, or to draw the flame out from the combustion chamber and have something like flame rollout and a fire. And under worst case depressurization, we test for spillage, which is those combustion gases coming out of the vent instead of venting up them, testing the actual draft, the pressure of the draft to make sure that it's in a safe range, testing truly for the carbon monoxide, the count of carbon monoxide that the combustion appliance is producing, versus what's also in the ambient coming out and happening in the ambient around the combustion appliance, and doing those carbon monoxide tests on the oven and stovetop as well. Also, just looking for, hazardous conditions to alert the homeowner to. The pressure and temperature relief valves on on water heaters. There's tremendous temperature and steam buildup that can happen in water heaters, which is incredibly explosive. And so the temperature pressure relief is very important on our water heaters. And so plumbing that, into a glass jar is not safe or helpful. Yeah, yikes. And plumbing them with a garden hose doesn't work either. So, just keeping your eyes open, using all of your construction knowledge, all of your building science knowledge, all of your good sense as you're going through a home to figure out, just everything that's going on and that you can help a homeowner with. So the home energy audit, it provides this vehicle for for a home performance company to gather the information about a house, from the occupants through those visual and diagnostic testing, just to get all of that information so that you can then turn around and present all your findings and recommendations and a full work scope to help that homeowner get to the goals for their home. And there's so many factors that you're looking at and that affect the home energy that you do need to become an expert in building science and the climate that you work in. And what you're doing is you're figuring out the moisture, the air, the heat movement in the homes, and all of those together are critical for the durability of the home, the energy efficiency within the home, the thermal comfort, the acoustical comfort, the indoor air quality, and the safety within the home. So that was the quick overview of the time spent in a home doing a home energy audit. Now we'll move on to, okay, so you've done the audit, you've got all this information and data, and now you need to compile all of that information and create a report and a proposal. And every project is different. Every house is unique. And so to a certain extent, you are designing a custom job for every house. The main issues are often the same. There's air leakage, there's some safety issues, there's some deferred maintenance issues, but the conditions of the home are different, and what's accessible and inaccessible, and what you were able to find out during the audit, and what you need to explore and find out further is all different. So a generic plan is just going to end up shortchanging both the homeowner and you as the contractor. So it's important to write an individual report for each home. So you provide this written report with your findings. It provides a preliminary, it should provide a preliminary work scope using your test in data to guide your post retrofit test out goals. And I find that homeowners really need help in prioritizing. And sometimes the recommendations can be staged. And if they can, that is often a huge relief to the homeowners. And then there is the times where you have to tell them that these things can't be staged, that they are contingent upon each other. And so that sometimes the staging question is a non-negotiable, in that, you know, I can't leave your house doing this in this condition for any length of time. And so that's the other thing, is that I call myself the truth teller, is that, you know, you need to tell people what are often the hard truths so that their expectations are managed and you're establishing that trust relationship. So you need to be the person that they know that they're going to get a true, honest answer from. So some guidelines for that site visit report is to restate the homeowner's concerns, and in their own words is great. You know, the point is that you're listening to them. And so you should be listening to them, and you should be listening to them carefully. So you should be able to restate what their concerns are, mostly in their own words, so they know that you are approaching this from the point of view that I want to make the home that you want. And now, you know, and I've got kind of all this more information that you probably ever thought you were going to get. And then we'll discuss, you know, what can be done, what can't be done, you know, what you want, what your budget is, you know, and come to that compromise. So describe the existing conditions, the results of the tests, make the recommendations that you have, and provide them with the test data and the pictures, and engage your homeowner. I've had homeowners that have turned to me and said, you know what, I don't want to know the side. Like, I don't need all that. Just tell me what needs to be done. And then I've had a lot of homeowners who want all that background and information and want to understand the tests and some of the science behind why I'm making recommendations that I'm making. The structure should be kind of a cover sheet, and you can be as creative, you know, as you want or not on that cover sheet. And then listing that client's concerns, their needs, their wants, and the things that the client knows about the house is kind of that part one. Part two is your measurements and observations and what you now know about the house and why those things matter. And then part three, your recommendations, the costs, the benefits, you know, and anything else that you feel like that needs to go in that report for that particular home. The work scope itself really can only be preliminary at this point. And it's often going to have an attic retrofit, crawl space retrofit if there's a crawl space, probably some building enclosure stuff, often heating and cooling or water heating or plumbing. It just, you know, that's what you found out, is what exactly it is that you can propose in that work scope. But it's definitely a description of the work that needs to be performed, you know, and kind of in ballpark pricing. So the typical work scope will probably include removal of some equipment. Very often the heating and cooling equipment needs to be replaced, fixing those deferred maintenance issues and moisture problems, correcting those wiring hazards that you've probably found, removing dirty and poorly installed insulation. poorly installed insulation often can be pristine and clean because it was unfortunately recently put in. In order to do the work around it, the air sealing and the deferred maintenance and that kind of stuff, it needs to be removed. And you get to choose as a contractor whether you feel like you can remove it and bag it and put it back in, or whether it's a lost cause. And those are some of those honest conversations that you need to have with homeowners. Air sealing. Air sealing is pretty much always an opportunity in homes. So definitely in crawl spaces, if there's crawl space present, and attic. Crawl spaces really need that ground source vapor barrier. There's no downside to putting in a ground source vapor barrier in a crawl space. Makes it way more pleasant to be in that crawl space and to work in it in the future and to examine it in the future and to find any issues in the future. Replacing any of those non-airtight can lights, or letting the homeowners know that they're going to lose areas of insulation if they want to leave those non-airtight insulation contact can lights in. We need 3 inches of space all the way around those lights, or some, and so even if we build a box, there's still that 3-inch perimeter around those lights that we can't put insulation. So that can be a lot of surface area with all the recessed lights that are in houses. And then installing right size HVAC equipment, including ductwork, since HVAC is an entire system and includes the ductwork. The ductwork needs to match the heating and cooling system. And then installing new installations, whether that's only in the attic or whether you feel safe making recommendations to put insulation in walls, or putting it on the floor of a crawl space. Those are kind of typical work scope items. So in summary, the energy audit is an opportunity to fully inspect a home. You need to use all of your observational skills, construction knowledge, building science knowledge, everything as you're going through the home. So being just, alert and on topic and on your game when you're out there in the house, finding all of this stuff out, using that diagnostic testing to further inform your observations, creating the work scope that provides value to the homeowner, include a test out of all your work. So part of your work scope should include the test out. That should just be part of the business model. It would be the part of a business model of a home performance contractor. And then take pride in the measured improvements that you've provided. So I did good. I have time for questions if people would have questions. Otherwise, we can call it a day a little bit early. And I want to thank you all for joining me today.
Thank you, Judy. And yeah, feel free to chat in any questions or unmute yourself at this point if you have questions for Judy. One question I had, Judy, is if someone is interested in learning more about a home energy audit or what it takes to do it, are there any resources that you have that you could reference to someone, or yeah.
There was a guide out there. I think it's by Saturn Resource Management, Saturn smri.org or something like that might be the website. Saturn Resource Management something. They have some guides for energy, the energy auditor. I haven't read over BPI's guide for a while, and I guess the thing about BPI is they're way general overview. They're not like specific, like look at this and learn this or whatever. So I don't really recommend wasting your time looking at BPI's guide, because it's not really a guide, but the Saturn, there's really, I think learning building science specifically about residential homes. So something like residential energy management or something like that. But Chris Dorsey wrote a book that kind of introduces you to building science, and it's an excellent book for an introduction to building science, which just having that knowledge helps you to start looking at your home differently, which is basically what the auditor needs to do. So yeah, and so other than that, hopefully we might get some more live sessions going on where all of this is being taught. And so I'd say, look out for live trainings.
Yeah, I think that'd be a great opportunity for us to work with you on hosting some in-person application of this, because I really appreciated all your pictures and graphics today. But yeah, actually getting your hands on it in person, I'm sure that really clicks a lot of these concepts home too.
Yeah, and the thing is that you see so many different things in different homes that even going to, one or two homes with somebody experienced, doesn't completely set you up for that home you go to finally on your own, and you're looking at something and going, I don't know what that is, but I know that it's something. And that's where pictures and just networking with, kind of finding a mentor, finding other people who are doing it so that you can, send out, text messages, pictures, whatever. It's like, have you seen this before? Do you know what this is? And just, like every house you're gathering some more just knowledge yourself. That is just going to be, become valuable for your future clients.
I see a few more questions in the chat, but I did have one from earlier that I received. From maybe the client perspective, how does a client find a home professional who can do a home energy audit? Is there a central resource, or just gotta do some sleuthing and kind of figure that out? And then are you currently doing home audits yourself right now as well?
So in answer to the first part of the question, it's difficult. There had been a tremendous effort to train up a home performance workforce, and it didn't produce anywhere near the home performance contractors that we hoped. So you really have to, looking for people kind of using the home performance is the first thing, but then you need to interview them when you talk to them to find out, are they, are they really just HVAC contractors? Because that's what some of them are. Are they really just installation contractors and not kind of looking at the whole picture? If they're not telling you that, are they just doing a clipboard audit? Because then it's probably just a salesperson from a company. And are they planning on spending like 5, 6, 7, 8 hours at your home? Gives you a clue as to just how well they're, what they're going to be delivering to you. Now, a home performance contractor can, does, and should use the audit basically as a loss leader. So they're going to charge you something. I don't know what kind of the few that are out there are currently charging. Probably about $700, I'm guessing, total guess, for that amount of time. So they're definitely losing money, but at least they're making, they're hopefully at least paying for that auditor's time out in the field. And that is, it's because it's part of that whole process of tests, make recommendations, make the plan, be the contractor that actually gets the job and fixes the house. So that's where they make it up. And some of them actually will even give you back. So, that $700 in the total price of the project. So it just, depends on their business model, but they can afford to do that, since what they really are is contractors, and that's where they make their money. As an independent third party auditor, I have to charge for all of my time, out in the field, for all of my time writing the report, for all of, for then the hour or two that I promise you in terms of discussing the report, answering your questions, delivering all the information, potentially also helping you to find a contractor to do the work, since unfortunately I'm not a contractor. So my business model definitely nowadays makes it very difficult for me to do an audit in somebody's home, because I have to charge a lot of money. And so so yes, sometimes I do audits, but honestly, I often talk people out of hiring me because I don't have enough contractor resources to recommend that homeowner to in the area, in that area where the homeowner has called me from. And I don't, so I have that honest conversation, is that I can do the audit of your home. I can give you all of this information. I cannot make a recommendation to you of who can or will do this work properly. So it's up to you. Do you want to pay me all this money to give you this information, and us not kind of be able to take that next step and know that we're actually going to get your home fixed? And so, that's kind of where I am with energy audits, is that I'm happy to talk to people, give them the options, decide whether it's worth it for me to come out and actually give you this information about your home. I way more prefer it when I get a call from somebody and I'm like, okay, I've got a contractor in your area, let's talk. And because unfortunately there are a few home performance contractors out there that haven't been able to figure out how to put it within their business model. And so, they will often actually refer me when they get the call, is that they'll say, call Judy, have her do an energy audit. We'll look at the report and, and talk to her about it. She'll give you the report. She's completely third party, but we, can kind of work and so that happens too.
Okay, thank you. And yeah, you mentioned, maybe looking at their checklist, what they're going to be doing, looking, how long will they be at your site or house. But one more question in the chat: are there any other certifications or trainings one might look at when evaluating a home performance professional, or that someone could get to?
So once again, I'm the truth teller. So I'm going to tell you quite honestly that there is no certification or training out there that will guarantee that you're actually getting somebody who will do a good job for you, who will do a good audit for you. None. So it's tough. And so it's so unfortunate. The homeowner shouldn't have to become an expert in what the person they're hiring is supposed to be an expert in. But at this point in time, the homeowners does need to have some basis. And if the people are not talking to you about how heat flow and airflow and water move in and around your home, if they're not talking about air sealing, if they're not talking about the fact that your HVAC system is a total system, including the ducts, those are all clues that they're not really very versed in the building science and may not be giving you, what you think you're spending your dollars on and having them come out to your home. So,
okay.
Yeah.
Yeah.
Forgive me for shouting out, but Judy, where are you located?
I'm in Southern California. I'm in the Los Angeles area.
Okay, thank you.
Yep. And I'm seeing in highly segregated microclimates like the San Francisco Bay Area, how do you select appropriate Met data versus major city center defaults? So one of the best places to search is a load calculation software such as RightSoft, because there are a lot of microclimates listed for California in the ACA information, in which sometimes I have problems with the ACA information, to be honest. ASHRAE's information is way better. So there's ASHRAE, ASHRAE, ASHRAE information and out there to help us figure out kind of the climate data for all of the various microclimates. And part of it is just kind of diving in, and like that first one that you do, you might, you're going to be spending more time trying to figure stuff out. And then as you get to do more homes in the area, you start figuring more and more out. Yeah, we've got lots of microclimates throughout California. And so it kind of depends on what data you're looking for, but I definitely look to ASHRAE and look for resources within kind of, like I said, load calc softwares, because I can find microclimates in there. And then the ACA manual, the manual J8, ACA manual itself has a lot of California microclimates and data in it. And also California Building Code, our energy code, has so many of our microclimates, and it is the design conditions that they want us to use, which is basically based on the ASHRAE information and over 30 years of compiled information. So those are some of the best places, and they're defensible, in terms of what we're doing. So those are where I look. And then in terms of kind of environmental conditions and things like that, there used to be something called scorecard.org. And I'm not sure if that website, I feel like I was searching for that website in preparation for this, and I don't think that's still there, but there are a number of environmental websites that you can look at. And so whether that's the AQMDs or some EPA sites, you can drill down and find in kind of environmental issues and brown field sites and things like that. It's a search, and that's partly also why you got to charge for your time. So what else I'm saying? So Dave is making a comment that he agrees with me. So of course he's now become one of my favorite people in the world. No. So auditing and tying that into a load calculation and a full HVAC design, including ductwork and airflows, it's all interconnected to achieving comfort and efficiency. Thank you, Dave, for that comment.
Great, and I know we're almost at time, but any more questions from the audience?
And you can reach me at this info@judyrachel.com.
Perfect. Yes, was just going to ask if folks can reach out to you. Good deal. All right. Well, with that, as we're coming up on time, do you want to just take a moment and say thank you, Judy? I found the presentation super interesting. I'm going to go take a look around my home the rest of the day. And just want to thank you for your time and your expertise. And thanks for everyone who was able to join today. Again, we'll send an email with a copy of the slides you can reference as well. Feel free to reach out to Judy or myself with any more questions. And we will be sure to hopefully see you soon on another training. So thanks, Judy, and thanks, everyone.
Yeah, thank you.
Thanks, Judy. Thanks, Sean.
Bye.
Bye.